The iDome is a testbed for pervasive computing and ambient intelligence research developed at the University of Essex. Based on student accommodation, the iDome uses intelligent embedded agents to learn user preferences and adjust its environment accordingly. There are many different devices in the iDome, all of which have been enabled to act as sensors or actuators associated with an agent. A number of different interfaces to the iDome are available. Access can be achieved via a computer, a personal digital assistant, a mobile phone, or any embedded Internet device. The iDome allows different intelligent agent approaches to learning to be developed and compared. The technique being demonstrated here is an unsupervised, data-driven, one-pass approach for extracting fuzzy rules and membership functions from data.
Our adaptive online fuzzy inference system works by initially monitoring the user in the environment and capturing a set of data from their interactions. The data is then clustered using a double clustering approach, which extracts a set of membership functions from the data. The membership functions are then combined with the existing data set to then generate a set of fuzzy rules. And this forms a fuzzy logic controller, which then controls the environment on behalf of the user.
This approach has been compared with three other soft computing techniques: genetic programming, adaptive neural fuzzy inference, and multi-layer perceptron. The results show that this approach has outperformed these other systems. The graph shows the rate at which new behaviors are learned over time. An initial period of rapid learning is followed by a flattening of the curve, indicating that no new behaviors are being learned. The video will be showing an adaptive online fuzzy inference system demo. The default conditions for the empty room are ceiling lights on, blind drawn, desk slam off, MP3 off. In this scenario, the agent has pre-learned a set of behaviors from previously observing the user in the environment. When the user is sitting at the desk, the agent will start the MP3 player, switches the ceiling lights off, and switches the desk lamp on.
50,000 tears I've cried.
The other devices in the room are switched off and the blinds closed. This is called sitting at the desk behavior. There is another behavior associated with the user standing or walking around in the room. Here, the agent stops the MP3 player, switches the ceiling lights on, and switches the desk lamp off. All the other devices are switched off and the blinds remain closed. The agent continually monitors the state of the room and the user's activity, and controls the environment by activating appropriate learned behaviors. Finally, a third behavior is associated with the user lying on the bed. In this case, the agent switches off the ceiling lights and switches on the bedside lamp. All the other devices are switched off and the blinds remain closed. When the user gets up, the current behavior for standing or walking about is reactivated. Because of the limited computational capabilities of the agent, in this prototype the responses are quite slow. It may seem illogical to start the MP3 player when the telephone is picked up. But this reflects the user's previous behavior and illustrates the fact that the agent learns from the user. The user now decides to alter the sitting at the desk behavior. He overrides the agent controller and switches the desk lamp off. He opens the blind, this time I'll save myself, but leaving the other devices unchanged. The agent has now adapted this particular behavior online to suit the user's changed preferences. The existing learned behaviors associated with standing or walking around in the room as well as lying on the bed remained unchanged. Here we see the room behavior appropriate to walking around. Here we see the room behavior appropriate to lying on the bed. Here we see the room behavior appropriate to walking around again. However, the next time the user sits at the desk, the new altered sitting at the desk behavior takes effect.
Now I will tell you what I've done for you. 50,000 tears that cry, screaming deceiving.
The agent is therefore able to adjust its initial set of learning behaviors online to suit the changing preferences of the user. The agent can adapt to changing conditions of the environment and user activity over a long period of time, allowing learning to be lifelong. When the user leaves the room reverts to its current default behaviors for an empty room. This is the embedded agent used in the iDome. The iDome is planned to expand into a two-room facility, allowing multiple agents and multiple occupants. A new building is taking shape on campus to house a new research facility, expanding the capabilities of the iDome by magnitude. This new research facility will be called the iFlat and provide a two-bedroom flat-like environment for the expanding research field of intelligent inhabited environments.